So tidy data is something we know that the majority of data analysis is data cleaning. We have to make sure that the data is clean, that it's ready to use in our data analysis and machine learning. And the common problem with many companies and a lot of these data sets is that a lot of the data that we get is messy. And in fact, a large portion of the data, making sure that it's in a user-friendly format, making sure that all of the columns, all of the rows contain very little null values, all of the column headings are properly formatted, all of the data points in the data set are properly used and formatted correctly. And a lot of this initial process takes time, effort, and energy that's time and energy away from actually doing the analysis and doing machine learning. And so we know that majority of data analysis is data cleaning. We know that messy data sets are incredibly common. So in this paper argues that three critical ways that we can make data more tidy. The three characteristics of tidy data. First is that each variable has its own column. We don't have an instance where we have multiple variables having in one single column. We have every single unique variable is allocated to its own column. Next is each observation having its own row. A lot of times, sometimes you may have multiple observations in one row, or you may have very ambiguous observations in or duplicate observations in rows. We want to make sure that every observation is allocated to a single row. And finally, every observational unit is represented in a table. Multiple observation units or multiple pieces of information are not encompassed in a table, but in fact, each table stands on its own in terms of representing an observational unit. And so a lot of the problems with untidy data are that column headers are sometimes values. We have multiple variables in the same column, and we have pivot longer and pivot wider in R that actually represent untidy data points. And so one of the common examples you'll see is that you'll see the column headings actually being the values, which is what the result is of pivot longer. But what we want to make sure is that we have tidy data, and the way we get to that is by making sure that each has its own column, each observation has its own row, and each observational unit is represented in a table. By doing this, we make sure that our data is more clean, it's more readable, it's more interpretable by not just other people, but it's more interpretable when you're doing your data analysis, when you're doing your machine learning. And so the importance of clean data is critical and cannot be understated because obviously the data is the crux where we build our insights and analysis and machine learning models off of. So that's a pivotal concept that we learned from this research paper. Next, if we go into chi-square test of independence. Now, if we have two different groups, let's say we have group A and group B, we have a distribution of their counts of the grades. So group A 40, B 30, C 42. Group B got 50 A's, 62 B's, 38 C's. If we want to find a way to see if these two groups are independent or are they related to one another in terms of the distribution of the grades. So if we want to answer the question, are the distribution of grades for one group different than the distribution of grades from another group, we would use the chi-square test of independence. This is used to measure the independence of two different categories. In this case, we're measuring the independence of the distribution of grades for group A against the distribution of grades for group B. If we do see a statistically significant difference, then we're able to detect that through this chi-squared significance independence test. So the way we do that is first get the expected counts for these groups. And so the way that we do that is through multiplying the row total by the column total and dividing it by the overall total. That's our expected value, that's our expected counts. And when we see what the difference between the expected and the observed portions are, that's how we get the chi-squared distribution. So the chi-squared statistic is the sum of the observed minus expected squared divided by the expected. And so that's how we get our chi-squared. Again, as we mentioned before, our expected value is row total times column total divided by overall total. So once we have our expected number of counts, we're able to get the chi-squared statistic. able to get our degrees of freedom, which is R minus 1 times C minus 1, or the number of groups minus 1 times the number of categories minus 1. And then we're able to use our standard p-value procedures to see if this chi-squared is actually significant. And so whenever we have two different groups, whenever we have proportions of different categories, and we want to see if these proportions of these different categories among two different groups are significantly different, we would use chi-square test of independence. Next is two proportional z-test. Now, in chi-square test of independence, we had multiple categories. If we only want to see if there's a statistically significant difference between one category in one group and that same category in another group, we use two proportion z-test. So if we're looking at the proportion of A's in group A versus the proportion of A's in group B, then that we would use two proportion z-test instead of if we're looking at the aggregate distribution of grades in group A versus the aggregate distribution of grades in group B. That's chi-squared. But if we're looking at the individual categories themselves, if we're only looking at one category at a time, and we want to compare the proportion of category in group A to the proportion of grade A in group A to the proportion of grade A in group B, then we use two proportion z-test. So another example is the proportion of, let's say, smokers in group A is 60%, proportion of smokers in group B 40%. Is there a statistically significant difference in the proportion of smokers between the two groups? So that's because we're only looking at like one category, that's when we use two proportion z-test. And so we have the standard error that we can use to actually get what the error should be, the standard error when we're doing this. So P1 hat is x1 plus x2. So these two represent the number of counts of the proportion. So this would represent the number of smokers in group A plus the number of smokers in group B over the total number of people in group A plus the total number of people in group B. And that's our P1 hat. That's our P hat. And then our N1 and N2 are the respective populations or of the groups. And then we're able to get our z value, which is P1 minus P2 over the standard error. Next, we have the entire idea of cognitive reframing or creativity or restructuring an event to fit, restructuring an event to make sure that you're setting yourself up for challenges, you're intellectually being stimulated, you're reframing a situation, reframing your thoughts in a way that are more energetic, positive, and encouraging and uplifting. And that sparks more creativity and energy. Now, if we go to some exam FM review, let's go to reviewing the entire concept of bonds. So we have our time, we have our payment, which is FR. So time starts at 0 all the way to N. FR is our coupon amount. We have the interest due, which is always I times b t minus 1. We have the write up or write down. Again, write up meaning we're going from price to the redemption amount, meaning that it is a discount bond in the sense that price is lower than a redemption, and then the opposite is true for write down. Write down is referring to a premium bond where a price is greater than the redemption, where we're writing down from price to redemption. And then we have our write up or write down. And then for this, we know that's FR minus CI or times VN minus T plus 1. And then we know that the book value is FR minus CI ANI plus C, or ANI minus T plus C. Now, some of the common things here, we know that the sum for any given time, the sum of the interest due plus, or interest paid plus the write up or write down value is going to equal the payment value. We know that the book value can be calculated using two ways, the retrospective and the prospective method. We know that if we're at, let's say, at time t, we know that at time t plus 1, that is going to equal the book value at time t times 1 plus I minus that payment value. And then we also know that the book value at time t plus 1 is going to equal that book value, the previous book value, minus that write up or write down amount. And so we know these two equations to hold true. We can use that to solve many of these book value problems. Another way is by using present value and future value. So if we have book value at time 5, if we have book value at time 8, this can be our present value. This can be our future value, negative portion. And we're able to get, we know the payment is FR, and if we need I, we're able to get I as well through this simple calculation by setting the present value to be book 5, future value to be the negative of BV8, because we'll be receiving that, and then FR will also be negative as well. And we're able to get I there. So that's if we have these two book values and I is an unknown, we can use this. If we're looking at in the case of loans, again, similar idea where we have time, where we have payment, which is typically just R all the way to N. We have interest due, which is R times 1 minus Vn minus T plus 1, or I times the previous book value. We have the principal repaid, which is RVn minus T plus 1, and then we have the book value, which is RA n minus T. And again, it's very similar to how bonds are structured in the sense that the sum of the interest due and the payment and the principal repaid at any given time will equal to the total payment amount. The total principal repaid amount will always equal to the original loan. We know that how do we get from one book value to another book value? Well, that is by simply subtracting the principal repaid at that next time step. So for example, the book value at 6 is going to equal the book value of 5 minus that payment, the principal repaid payment at 5. So that's one way. Another way, obviously, is through accumulating the previous book value by the interest minus subtracting the payment that was done, not FR. So that would be R. And then another way is through that PVFN calculation on your TVM keys. So that is a review of loans and bonds. And then if we go to MACD, so MACD refers to when the cash flows are occurring. It's a representation of when the cash flows are occurring in an investment time diagram or a set of cash flows. So it refers to when cash flows are occurring in a set of given cash flows on a time diagram. And then a couple other things, annuities. We want to make sure that we are being very precise and exact with the language of where each time terms are. So if it's monthly, we want to make sure everything is in months. If it's annually, we want to convert everything to year. And so that's a few concepts in FM that I'll stop here today. Thanks.